In this lesson, we're going to look at some more work on interpreting histograms, and we're going to be estimating frequencies from parts of the bar where no scale is given on the frequency density axes. So we did some of this last lesson when the frequency that we were given was for a whole bar, and this is what we called the key to unlocking the frequency density scale. So that's what you should have done for your starter question. We'll have a look at the solution to that in just a minute. And then making that slightly harder is when the frequency we're given, that key that we're given, is across 2 bars, so it's not for a whole bar. So looking at the question that you did for the starter when the frequency is for the whole bar, so your key to unlocking the scale, this time you were given the frequency for the first bar, which enabled you to find the frequency density scale because you could find the frequency density of the first bar was 8 and fill in the rest of the scale from there. Then to estimate the number of people between 55 and 75, if we draw lines at 55 and 75, we can then work out the areas of each of those parts of the bars and add them together to get a total number of 120 people. So let's move on to the slightly harder version of this question when the frequency is across bars. Now, if you have a printer, I suggest that you print this off and fill in the sheet as we go. If you haven't, you might want to draw it out in your notes books. So if we notice for this question, here is our key, where we are told that 42 leaves measured 25 millimeters or less. So I've put a red line here on my histogram at 25 millimeters, and we can see that's not whole bar. So it's not as straightforward as dividing the frequency by the class width to get a frequency density on our scale. So what we're going to do now, we are just going to use the small squares on the grid of our graph paper to calculate areas, because the 42 leaves still represents an area on our histogram. So if we look at our first bar, our 10 to 20 bar, we can't work out the area using our scale because we don't yet have a scale on the frequency density axes. So what we're going to do is we're going to work out the area of that bar in terms of small squares. Now it's pretty small and quite hard to see, but I can see that that is 5 small squares across and 4 small squares high. So I've got an area of 20, and I'm going to use SS for small squares. For the part of the bar I want for the 20 to 40 group, here I'm going up to 25. Now it's pretty small, but I can see that that's 2.5 small squares across, and it's 5, 10, 15, 20 small squares high. So I've got 2.5 times 20, so that gives me 50 small squares. So 20 and 50, that actually adds to 70. So over here, if you have a look, I've got 70 small squares represents 42 leaves. From that I can work out what 1 small square is equal to. If I divide 70 by 70 I get to 1, so I've got to divide 42 by 70. So that tells me that 1 small square, if I do 42 divided by 70 on the calculator, is 0.6 leaves. Okay, so now everything I do in terms of working out areas is going to be in terms of small squares, and I've actually got no need to work out this frequency density scale at all. So let's have a look then at part B, work out how many small squares represent 60 millimeters or more. So again, the first thing I'm going to do here is I'm going to put my line in at 60 millimeters so I can divide up that last bar. And now I need the area of this section of the bar that's more than 60 millimeters, and I'm going to get that area in terms of small squares. So for 60 millimeters or more, how many small squares I'm looking at? Well, it's 7 small squares across and 15 high. So that's equal to 105 small squares. That's the area of my 60 or more millimeters. So I now want to convert that area to a frequency. So that's when I'm going to use this key that I worked out over here. So I worked out above that 1 small square is equal to 0.6 leaves. So if I want to know what area 105 small squares is equal to, I need to do 105 times 0.6, and that's going to give me 63 leaves. So that's the answer to my question. Okay, so this says to try this one. This is actually on your question sheet. So what I'd like you to do now is to go to the worksheet for this lesson, which is detailed on the assignments.